In this lecture, we will see what is confidence interval. So far, we have seen distribution, data, and distributions part of it. Now, confidence interval comes into picture whenever we have a sample data. So, when we have sample data, we will be calculating mean and standard deviation. Like mu is mean and sigma is standard deviation. When we are going to calculate the mean for any sample data, we should be certain about how much confident we are telling this would be the mean for the total population as well. Okay, so this is a sample data considered, and the distribution is going to represent for this sample data alone, and I have a certain mean value. Now, how much I can be confident for this data? So let's say this is going to represent the sample from some value between x to y, but the total range can be minus infinity to plus infinity, the actual population which I mean. When I'm going to say for this sample, this is the average. So if I'm going to attach a confidence values like mean plus or minus, say 5, 10 or some value in addition to this, that will be called as a confidence interval. Say my average is 90 and I can say 80 to 95 is the total range of my confidence interval. Now to calculate this, it is given by a simple formula: mean plus or minus t score into sigma by root 10. This gives me the minus value gives the lower bound and positive value gives the upper bound of confidence interval. So what this tells us is, in the total number of samples taken, this sample represents the total population which has a mean of so and so value, and this is the confidence interval. We can be certainly confident our entire data, the total data itself will have only this much as the mean, and the range within which this mean can be is going to be given by the confidence interval. And this confidence interval we can define some percentage, like 90% confident what would be the value, 95% confident what would be the value. This 90 or 95% confidence value will be calculated by the t-score here. So this t-score comes from the PPF formula which even we saw from previous introduction levels. So PPF is the inverse of CDF function, cumulative distribution function. So using PPF, say if my confidence interval is 95%, in the PPF formula I will be putting in 99.5 as the value. So meaning it will be 0.995. Whatever the value comes in turn, that we will replace here. So this is going to give me an idea of, out of total population, if I am going to consider a sample and that sample's mean, how much confidently I can believe in it. That is the value, that is the outcome of calculating the confidence interval. The same code example is given. We will see it next. I have already created a function which is going to calculate the confidence interval. So I am going to call this function and this function gets executed. So here the distribution under consideration can be of two different types. Say for example, it can be a normal distribution function, in which case I will be directly using norm.ppf, which we have used before also, or it can be a t distribution. So there is a slight difference between normal distribution and t distribution. Normal distribution represents a population data, whereas a t distribution represents a sample data, but still it will be normal in nature. Using this also I can calculate the PPF value, the point percentile function. So in this case, say I want to calculate PPF. So from the beginning we will start analyzing the code. So first I am reading the input data mba.csv and calculating the mean value. So mba data frame gmat is the column dot mean, and similarly to get the total number of values dot count I will be getting the n value. Standard deviation dot std, I have calculated all the required values. If suppose my distribution is going to be either t or z, either t distribution or normal distribution, accordingly my if elif condition will be executed. So this value comes as a function parameter also as well. This I have kept as a keyword argument input parameter, which is optional. So these are side notes which I am giving you as hints. Okay, assume this is t is the input given right now. For t, my test stat will be stats.t.ppf of 0.995 comma n minus 1. So this n minus 1 is the total number of values minus 1. This can be called as degrees of freedom as well. Whenever we are going to consider only a sample information, in that sample information the total number of samples will be termed as the degrees of freedom, and usually the degrees of freedoms will be total minus 1, because the one value will be taking at any point of time, and that self should be subtracted, that single value should be subtracted. That is why n minus 1 is being used here. And this 99.5 meaning we are calculating 0.995 meaning we are calculating 99.5% what is the total number of marks scored, and with a confidence of it will be 0.05. So here we are going to sorry, it's not confidence, this is a 99.5% is the confidence we are taking here. So this test stat is 0.995 input given, and this value is okay. Now consider my provided confidence interval is 99.5%. Say I want to say with 99.5% confidence what is my output. So in that case I can either consider the distribution under as t distribution or z distribution. T distribution will be used when only a sample data is considered. Z can be used when my total population itself is considered, then I can use Z distribution. The inputs for which method variable comes from the function argument, which is a keyword argument in fact here. Okay. First, I'll take the T distribution here, consider T distribution. So stats.t.ppf 0.995, which is the confidence ratio which I want to calculate, and comma n minus 1. Here n minus 1 represents the total number of samples under consideration. So this can also be termed as confidence, this can also be termed as degrees of freedom. So usually degrees of freedom comes only when a sample is considered. So this t test includes an additional argument. And after calculation of this, we are going to substitute this in the formula what we saw. Mean minus t score into standard deviation by square root of n. And to calculate the upper bound, I am going to use the plus symbol here. So when I am going to call the print statements, this will be print to the command output. So same function, I am calling it below and then executing the code. So this gives me 708 to 713. So with 99 point confidence interval, I can say my output will be in the range of 708 to 713. Okay, so this is the example for confidence interval.